On March 13, 1989, a Liberian chemical tanker had a massive engine room explosion and fire near the coast off central Japan. The tanker was carrying 25,700 tons of chemicals, including 7,000 tons of highly toxic acrylonitrile and various amounts of caustic soda, styrene, and methanol. The explosion was of such a magnitude that the ship's crew was not able to send a distress signal. Fire and rescue teams could not board the ship due to toxic gases, fire, and continuing explosions. The tanker burned for 5 days before sinking. All 23 crew were killed.
The safe handling of nitriles is critically important to everyone involved in nitriles operations. The health effects associated with exposure to these chemicals are severe and possibly life-threatening. Like any dangerous situation, we can limit or eliminate the risks if we are aware of these factors that lead to unsafe conditions. Innovine is committed to helping all of us stay healthy and safe on the job. After all, you should finish your day just as you started it, safe and secure.
Innovine transports large volumes of nitriles, and therefore the risk of injury is always present. It is our responsibility to reduce that risk and, where possible, eliminate it. Together we can accomplish this if you know the characteristics and hazards of dealing with nitriles, the importance of protective equipment, and how to respond if you or someone else is exposed.
You must know how safe loading operations are conducted. You must pay attention to detail during preload activities. Observe all safety guidelines during loading and follow safe practices during post-load activities such as sampling and gauging. These are all vital components of accident-free operations.
Acrylonitrile is a clear, colorless liquid with a strong, sharp odor. It vaporizes easily, and it's flammable. Its vapors are heavier than air, and it can accumulate near the floor in unventilated spaces. If it's mishandled, the substance can react violently with other chemicals. Its vapors are not inhibited, and it can polymerize. Acrylonitrile is acutely toxic and will cause serious burns if swallowed, inhaled, or if it comes in contact with one's skin. It also causes eye and respiratory irritation. In addition to these acute effects, there are chronic effects from prolonged exposure. Acrylonitrile is a suspected cancer-causing agent, and exposure may result in skin, thyroid, liver, or nervous system problems. For these reasons, those working around nitriles should be given an initial physical examination, periodic health checks, and a termination exam at the end of their employment. Acrylonitrile normally looks like water. However, it is most hazardous when it presents a hazy or yellow color. It should be kept out of direct sunlight and away from heat sources, since this may result in color problems or a dangerous reaction. Do not deadhead pumps, as this will cause the pump to overheat and create an explosive hazard. Acrylonitrile may react violently when exposed to incompatible chemicals. These chemical reactions may release enough heat to create an explosion. Incompatible chemicals include copper or copper alloys, ammonia, caustic substances, strong acids, amines, and peroxides.
Preload operations are a critical part of the nitriles loading process. Attention to detail during this stage in operations is probably the single most important way to avoid serious accidents.
Preload operations consist of a preload meeting and cargo hold inspections. During the preload meeting, everyone involved in nitriles loading discusses the game plan, the strategy for winning a safe game. Cargo hold inspections are necessary to ensure the nitriles do not become contaminated with substances that destroy their value or threaten anyone's safety. The preload meeting should include everyone who will play a part in the nitriles transfer operation, on the dock and on the barge. In this meeting, the participants confirm all transfer documentation, that the proper PPE is aboard, and that adequate communications are available. PICs, or persons in charge, are also recognized. These individuals will give the stop-start orders. Transfer documentation should consist of the declaration of inspection, voyage orders, and the ship-to-shore checklist. For ships, agents should supply papers 20 days before estimated time of arrival. A prior cargo list for the nominated tanks should be made available, in addition to an MSDS for acrylonitrile. The declaration of inspection must be completely filled out and signed by each person in charge before transfer operations are started. The voyage orders and caustic letter must be available to the person in charge before any transfer operations take place. The transfer orders contain the plan for each product to be transferred. The caustic letter contains information on the previous or current location of caustic on the vessel. It must be confirmed that caustic was not the previous cargo and that nitriles will not be loaded adjacent to or diagonally from caustic. The ship-to-shore checklist ensures everyone will be able to communicate during the transfer. The PICs must speak English. The PICs should agree on an emergency backup method of communication, should primary communications fail. This may include an air horn, flashing light, or other signals to alert the intended PIC.
The preload meeting also covers any other information that is relevant to safe transfer operations. This includes having unexpired acrylonitrile Draeger tubes on hand and the antidote kit, also called a Lily kit. The Lily kit contains antidotes for cyanide poisoning, the result of exposure to acrylonitrile. A responsible person should ensure that trained medical personnel are available to administer oxygen and the Lily kit.
Other important preload activities include inspections of the loading equipment and the cargo tank. Before any transfer operations begin, several pieces of equipment need to be checked. All piping, flanges, and hoses need to be inspected for dirt, water, and residual chemicals. Coast Guard-approved flanges with alignment pins must be used. Steam coils must be blinded on all tanks receiving nitriles. There must be a loading arm or hose and a vapor arm or hose on all transfers. Runaround hoses and U-bin piping arrangements are acceptable. All lines must be pressurized with nitrogen and a soak test performed to check for leaks. Keep in mind, framing around the tank can trap hazardous vapors, such as nitrogen. Safety showers also should be checked before transfer operations begin. Next, the cargo tank must be inspected to ensure it is ready to receive the nitrile. The tank is inspected under strict guidelines to make sure it is clean, dry, and odor-free. The tank must be tested for oxygen by the master, chief mate, or other responsible officer. It also may be tested for hydrocarbons or toxic gases depending on the nature of the last cargo. An oxygen meter is used to determine if there is sufficient oxygen, at least 19.5%. If the oxygen is below this level, the tank must be ventilated before anyone can enter. The tank must be retested after ventilation and just before entry. Only when the surveyor has certified that the tank is ready to receive nitriles can the transfer start. The test for hydrocarbons ensures the tank does not contain an explosive atmosphere. The LEL, or lower explosive limit, must be below 1%. Depending on the nature of the previous cargo, tests should be performed for specific toxic chemicals, such as benzene or hydrogen sulfide. Readings should be taken at different levels within the tank and from as many tank openings as possible. If the tank atmosphere is satisfactory, then the surveyor will enter the tank to conduct the inspection. The entry into any tank, in this case a cargo tank, is known as a confined space entry, or entry into an enclosed space. This is one of the most dangerous tasks undertaken during transfer operations.
Confined space entry has led to a number of injuries and fatalities aboard barges and tankers in the marine industry. Any confined space should be approached as potentially lethal until proven otherwise.
In order to ensure safe confined space entry, Innovine has identified 7 safety rules that must be observed before confined space entry can proceed. First, all other options have been ruled out. A permit must be issued by a responsible person for each tank to be entered. The permit must be communicated to all affected personnel and posted at the entry point. All persons involved must be competent and able to perform the work. All sources of energy affecting the space must be isolated. Testing of the atmosphere in the tank must be performed and repeated as often as necessary. A hull watch person must be stationed at the hatch during the tank entry. And finally, unauthorized entry must be prevented. Here's how a safe confined space entry is performed.
Have you got a portable gas detector with you?
Yes, sir. Right
Great.
here.
Will the ventilation be running while we're in the tank?
Yes, sir. We'll keep the fan running
Right.
while we go down.
What about illumination? Have you got a flashlight?
I've got a good
And
flashlight
I've got
and
one as
batteries.
well. Rescue and resuscitation equipment, will that be available?
Yes, sir. It's on the manifold now, but we'll bring it out
Bring
if
it
you
down
like.
here, okay.
Okay.
And will there be a trained person in standby while you and I are in the tank?
Yes, sir. Once I go inside with this permit, I'll get a lookout, and he's well
Okay.
trained in all the procedures.
The surveyor and chief mate conduct their tank inspection to make sure all of their preparations are complete before entering the tank. They inform the officer of the watch about their planned entry and confirm the entry permit is signed and complete. Everyone agrees no other transfer operations will take place while the inspection is in progress. Before entering the tank, the crew reviews its emergency and evacuation procedures. Radios are tested, and a procedure is agreed upon to establish contact every 5 minutes. The rescue equipment is approved for confined space entry. Moreover, it is inspected regularly to ensure its performance in the event of an emergency.
Confined space entry kills dozens of people every year. What leads to these fatalities? Permits are not followed, PPE requirements are often ignored, nitrogen dangers are not understood, simultaneous operations take place during the entry, there is poor lighting or inadequate ventilation, and most of all, a lack of training. Spending extra time during the preload phase of operations always pays safety dividends. Prevention is the name of the game. Just as preparation is important in preload operations, protection also is important during loading operations.
Loading operations take place after all designated tanks have been inspected and are ready to receive nitriles. Although there has been significant preparation up to this point, the loading period is not the time to relax. Safe handling of nitriles during transfer operations breaks down into 3 main areas. The 3 Ps: planning, procedures, and protection. Let's take a look at each of these to see how they can eliminate safety hazards.
Well, we wouldn't have to have this meeting.
Planning the transfer of nitriles gives everyone the opportunity to identify potential hazards and to take actions to avoid them.
We run a risk of it.
First, make sure emergency response preparations have been made. Know who to call and how to make that call. And be aware of port regulations that govern notification of emergency response actions. Only qualified personnel should be involved in the transfer process. Hoses should be tested and marked for nitriles use. The vessel fire system must be fully operational, and electrical systems need to be in compliance with port regulations.
An important part of the loading process is the need for understanding the procedures observed during the transfer. Everyone involved in the transfer needs to know what their responsibilities are and what part they play in each stage of the operation.
Those involved in the transfer of nitriles must know how the ship connect and manifold lineup will occur, the amounts to be transferred and the transfer rate. Understand how first foots will be handled, the capacity of the shore side tank or tanks, whether a shore stop or ship stop will be used, and how open communications will be maintained between ship and dock personnel. The importance of periodic rounds by the PICs to monitor pump rates, tank levels, loading equipment, and mooring lines also should be covered.
The third part of successful loading operation is protection. Personal protective equipment is all that stands between you and a serious chemical exposure. Think of PPE as your lifeline.
There are 3 basic levels of protection. Level C PPE is used for sampling. This level calls for a 1-piece hooded chemical-resistant suit and a full-face air-purifying respirator with a canister-type filter for removing hazardous vapors. A 2-piece suit with coveralls and a long-sleeve jacket can also be used. Level B PPE, required for loading operations, calls for a full-face respirator for eye and respiratory protection. The respirator is supplied with air from an air pack, like the one shown here. This device is called a self-contained breathing apparatus, or SCBA. An air hose also can be used. However, the SCBA provides a greater degree of flexibility. Level A PPE is primarily used in emergency response situations. It requires an airtight 1-piece suit with a face mask and respiratory equipment. Rubber boots and 2 pairs of chemical-resistant gloves complete the protection, regardless of the PPE level. One glove should be a thin inner type, covered by a thicker butyl rubber glove. Teflon and neoprene gloves provide only limited protection. Openings around gloves and boots should be well taped, and special attention also should be given to the neck area.
Acrylonitrile exposure is a serious condition, and therefore it is critical to recognize the symptoms of exposure and respond quickly. Acrylonitrile causes chemical burns to the skin and other tissues, but these effects may be delayed since the release of cyanide begins at once and continues for several hours.
Symptoms of acrylonitrile exposure include eye and skin irritation, slow gasping breathing, initial brick red skin color followed by bluish face or lips, nausea and vomiting, headache and dizziness, anxiety and a feeling of suffocation, drooling, numbness, disorientation, protruding eyeballs, convulsions, and unconsciousness.
The best immediate action if nitriles is splashed or spilled on you is water, water, and more water. Here's an example of a good response.
Have someone call for medical assistance immediately. Remove the victim from the spill area, making sure the rescuers are in their PPE or personal protective equipment. Remove contaminated clothing. Flush the affected areas with large amounts of water, followed by washing with soap. Take anyone exposed to the hospital immediately. Time to treatment is critical. Double bag clothing for disposal, and discard any contaminated leather goods. After an exposure, administer oxygen, even if the exposure is mild. If the victim is unconscious, start CPR with a mask using a one-way valve or an ammu-bag, an airbag with a one-way valve and mask. Do not use mouth-to-mouth CPR. For a mild exposure with no alteration of consciousness, give oxygen and consider using the amyl nitrate from the antidote kit. Keep the victim on oxygen until a person trained to use the antidote kit arrives. For an exposure with a mild change in consciousness, administer the amyl nitrate in the Lily kit and consider using the sodium nitrite and sodium thiosulfate. For more serious exposures, including knockdown, the full amyl nitrate, sodium nitrite, and sodium thiosulfate antidote should be given. Make sure the physician knows the specific chemical that caused the exposure. In the case of nitrile exposure, the time to treatment is critical.
You've seen what is involved in preload and loading operations, including the procedures for confined space entry, the importance of PPE, and the response for nitriles exposures. The final step for nitriles transfers is post-loading operations.
There are fewer jobs to describe for post-loading operations, but these are still important to the overall success of the transfer. Post-load operations are critical steps in the loading process. Since they involve disconnecting loading lines and sampling operations, they also can be the most dangerous. Everyone on the vessel and on the dock must know the line clearing and disconnect procedures. All hoses and lines need to be cleared. Everyone involved in sampling and monitoring should be in the proper PPE. Sampling should be performed slowly and carefully at the best possible location to avoid exposures. This is the only time that acrylonitrile is open to the atmosphere. A transfer summary should be attached to any previously signed documents indicating any significant events during the transfer. Innovine should be contacted if any event occurs which needs follow-up to prevent unsafe conditions from continuing.
Innovine is committed to ensuring that the transfer of nitriles on ships and barges takes place without incidents that damage the environment or cause injuries to your people. We appreciate you taking the time to learn how we can all work together to reduce these risks to zero. Thank you. Please stay alert, act smart, and be safe.